Hello everyone, welcome back to the channel. Today I am going to continue the last year solutions for 3-mark questions. So generally 10 3-mark questions are asked according to the pattern of CBSE. So let's move on to the first question that was asked last year for 3 mark. So we have question in front of us. If A minus 2 comma 1, B A comma 0, C 4 comma B and D 1 comma 2 are the vertices of the parallelogram ABCD, find the values of A and B, hence find the length of its sides. So you are given a parallelogram ABCD in which you are given the vertices of A as minus 2 comma 1, B as A comma 0, C as 4 comma B and D as 1 comma 2. So you need to find the values of A and B first, and hence you need to find the length of its sides. So in order to find the value of A and B, there are various methods to do that. So first of all, you can use the property of parallelogram as opposite sides are equal and parallel. So you can use the distance formula as these two sides are equal and these two sides are equal. So that may be a bit complicated. So in order to go in an easy way, let me make the diagonals. So we have diagonals AC and BD. Let these two intersect at a point O. So we know the property of a parallelogram, the diagonals of parallelogram bisect each other. So we have OA is equal to OC and OD is equal to OB. Therefore O is the midpoint of AC as well as BD. So if O is the midpoint of AC, the coordinates of O in accordance with AC will be minus 2 plus 4 by 2 and 1 plus B by 2. Similarly, if we take in accordance with BD, coordinates of O will be, this is also the coordinate of O, 1 plus A by 2 and 2 plus 0 by 2. So for this x coordinate is minus 2 plus 4 by 2 and 1 plus B by 2. For this 1 plus A by 2 and 2 plus 0 by 2. So both the with AC you take or BD you take, both are O coordinates only, so we can equate them easily. So x coordinate if we equate, so 1 plus A by 2 is equal to minus 2 plus 4 by 2, 1 plus B by 2 is equal to 2 plus 0 by 2. So this we have equated this with this and this y coordinate with y coordinate. So just simplify it. 4 minus 2 is 2 by 2. A is equal to 2 minus 1, that is 1. Similarly, 2 cancels each other. 1 plus B is equal to 2 and B is equal to 2 minus 1, that is 1. So A and B both has value 1. So the first part of the question is already over. To find the value of A and B, both are 1. Hence find the length of its side. So finding length of side is very easy. You can just use the distance formula. Now you know all the coordinates of A, B, C, D. So just using simple distance formula, I will write the formula quickly. The distance formula is under root x2 minus x1 whole square plus y2 minus y1 whole square. So just using the coordinates, let's say we are finding it for AB, for example. So A coordinate is minus 2 comma 1. Let me write it here. A is minus 2 comma 1 and B is A comma 0. A you have already found out, so 1 comma 0. So let's say this is x1, this is y1, and this is x2, this is y2. So just substitute the values. X2 is 1 and x1 is minus 2 plus y2 is 0 and y1 is 1. So 2, 1 plus minus minus plus, so 3 square is 9 and minus 1 square is 1. So that come up to be root 10. So similarly it can be found out for all the other sides also. This was one of the question asked in 3 mark. Moving on to the next question. The next question asked was, find all the zeros of a polynomial 2x to the power 4 minus 9x cube plus 5x square plus 3x minus 1 if two of its zeros are 2 plus root 3 and 2 minus root 3. So we are given a 4-degree polynomial and we are given two of its zeros as 2 plus root 3 and 2 minus root 3. We need to find the other two zeros of the given polynomial. So first of all we need to know that the zeros that we are given, how to use that to find the other two zeros of the given polynomial. So zeros means what? The zeros here, the word that they have used, zeros, whether in the first line or the second line, what does that signify? Zeros in the sense, these both are the factor in the sense, these both are the solution of the given polynomial. That means the value of x is 2 plus root 3 and the value of x can be 2 minus root 3. If you substitute this value in the given polynomial, it should result in the value as 0. That's why they are called zeros of a polynomial. Similarly, if you substitute 2 minus root 3, so it should give up to the value as 0. And that you can try also at your home. It will result in 0. So that's why they are known as zeros of a polynomial or solutions. We call it in different names. So now how to use it to find the other two polynomials, because it is a 4-degree polynomial, so there should be 4 values of x that should satisfy this equation, this polynomial. So these two you are given, the other two you need to find. So we can write it in the form x minus 2 plus root 3 is equal to 0. You can simply write it just shifting into left hand side, and x minus 2 minus root 3 is equal to 0. So both things we can write, just simplifying it a bit, x minus 2 minus root 3 is equal to 0 and x minus 2 plus root 3 is equal to 0. So x minus 2 taking together, x minus 2 plus root 3. So now I want to explain you a simple concept. Let's say there is some number, let's say 48 or any number you can take. You are given that two of its factors or zeros or whatever you want to say. Two factors are 2 and 3. So you can easily say, okay, 2 is indivisible by 2 can divide 48, 3 can also divide 48. So if you multiply both these factors, that will result in 6. So if you check, 6 can also divide 48. You can simply say 6 8 is 48. So 6 is also one of the factor of the given number. So the conclusion is, if you're given two factors of any particular number, the multiplication of both of these factors will also be a factor of the given number. So the same concept I am trying to use it here. So you are given that this is a factor of the given polynomial, and this is also a factor of the given polynomial. So the multiplication of both of these should also be a factor of this given polynomial. So let's multiply both. Minus root 3 and x minus 2 plus root 3. This is only the reason. In order to multiply, I have taken x minus 2 in a different bracket and minus root 3 and plus root 3 separately to make an identity of a minus b and a plus b. That is a square minus b square. So a square minus root 3 whole square. So just solve it. X square plus 4 minus 4x minus 3. So x square minus 4x plus 1. So that is correct. So this we have found out one equation. Now how to proceed further to find the other zeros of a polynomial. So again coming back to the same example. So I told you, okay, 6 is a factor of this number that you must have agreed. Now how to find the other zeros? 6 is one of the factor of this. What is other factor? If you divide it simply 48 by 6, you will get 8 0. So if you observe, 8 is also the factor of 48. So the total in combined, what I am trying to say is 6 and 8. If you combine, they both are the factor of 48. The same concept if we use here, this is a factor of the given polynomial. So if you divide the given polynomial by this quadratic equation, you will get the other factor. So let us divide it. 2x to the power 4 minus 9x cube plus 5x square plus 3x minus 1. So we have to divide x square minus 4x plus 1. So if we divide, let's say it will be 2x square. So if you multiply both, you will get 2x to the power 4. Multiply this by 2x square, that will be minus 8x cube and 1 by 2x square plus 2x square. So for doing this, you need to know how to do a long division method to divide the polynomials. This you must have studied in your lower classes. So let us solve it quickly. It will be minus x cube plus 3x square, and in the further equation minus x cube plus 4x square minus x minus x square plus 4x minus 1. So you got minus 1 minus x square plus 4x minus 1. Then everything cancels out and you are left with 0. So ultimately you got a polynomial. By this long division you can easily say, use this base, x square minus 4x plus 1 into 2x square minus x minus 1 will give up to be this. That means this is also a factor of this equation and this is also a factor of this equation. So just divide, we are dividing it into two equation by splitting the middle term. That is 2x square minus 2x plus x minus 1 by 2x x minus 1 plus 1 into x minus 1. And just separate it, 2x plus 1 and x minus 1, and equating it to 0 to find the roots. So x will be minus 1 by 2 and 1. So you got the other two zeros of a polynomial as minus 1 by 2 and 1. If you have any doubt, just you can comment. I can again explain this because it's a bit lengthy question and it's very important question that is mostly asked in CBSE paper, so you should understand it properly, that how to proceed and how to reach to a answer. So let's move on to the next question, that is find the HCF and LCM of 404 and 96 and verify that HCF into LCM is equal to product of two given numbers. So you are given two numbers 404 and 96. First of all, you need to find the HCF and LCM of both the numbers and verify that HCF into LCM is equal to product of the two given numbers. This property you have learned in the first chapter of NCRT. So let's find the first of all, let me do the factors of both the numbers that are given, 404 as well as 96. Just simply dividing it, 202 and 101. Now 101 is a prime number, so there will be no further factors. Similarly for 96, 24, 12, 6, 3 and 1. So if we note down the factors as 2 into 2 into 101, 96 factors as 2 into 2 into 6, 1, 2, 3, 4, 5 times 2 and 1, 3. So I will just go with the basics only that you must have learned in very lower classes, maybe on 5th or 6th class, that how to find HCF and LCF. So HCF, we just take the common numbers of the both. So there are only two common numbers, otherwise there is no such pair you can form out. So just multiply these. HCF will be 2 into 2, that is 4. And for LCM, by this method only, whatever is common, you just write it down a single time, and all the other digits also you have to take into account. 1, 2, 3 into 101. So that will be 8, 16, 32, 96 into 101. That will be 9696. So the LCM is 9696 and the HCF is 4. So you have found out HCF and LCM both. Now you need to prove that HCF into LCM is equal to product of two numbers. Both the numbers that you were given, product of numbers. So HCF is 4 and LCM is 9696, and the numbers are 404 and 96. So you can simply check it. It should come out to be 38784 something. So it will be triple match. This was a very simple question asked in 3-mark question. Let's move on to the next question. On to our next question. Prove that length of the tangents drawn from the external point to a circle are equal. So we are given one circle and there is an external point A. From here two tangents are drawn, AP and AQ, on a circle with the center O. We need to prove that AP is equal to AQ. So let's solve this question. So first of all we need to, if we prove that this triangle, that is triangle OPA and the triangle OQA are congruent to each other, so we can say by a property of congruent parts of a congruent triangles, that is called CPCT in short form, that AP will be equal to AQ. So let's prove in triangle OPA and triangle OAQ. OA is common first of all, so we have one side that is common. The second thing is angle OPA is equal to angle OQA. They are 90 degree. Why they are 90 degree? Because a line from center of the circle to the tangent makes an angle of 90 degree. This is the theorem you must have heard of. So it is applicable to both the points Q as well as P. So the both angles are equal and they are equal to 90 degree. And the third is OP is equal to OQ. Why so? Because both are radius of circle. Radius. So you have three things. OA, if you see, is the hypotenuse. One side is equal, OP is equal to OQ, and you have one right angle. So they are congruent by RHS, right hand side congruency rule. You can say triangle OPA is congruent to triangle OAQ. Therefore, by CPCT, that is congruent part of congruent triangles, AP is equal to AQ. So that is the proof that these AP and AQ are the tangents. The length of tangents drawn from external point to a circle are equal. So this was a easy question and direct theorem based question. So you need to see the theorems also very properly. Many a times it is generally asked directly without any twist. So the next question that we have is, prove that area of an equilateral triangle described on one side of a square is equal to half the area of equilateral triangle described on one of its diagonal. So the most important part of this question is how to draw the diagram. So we are given that there is one square. Let's say this is the square. So one equilateral triangle is described on one side of the square. So let's take any side. Let's take this side. So there is one equilateral triangle that is described on this. That should be a straight line. Okay. And is equal to half the area of equilateral triangle described on one of its diagonal. So on one of its diagonal, let's say this is the diagonal, there is one more equilateral triangle. Equilateral triangle is what? That all the three sides are equal. So let's say the side of a square is A. So these all will be A only. Because this is the equilateral triangle, the base of this equilateral triangle is A, so others it will also be A. So what will be the diagonal? So take this triangle. So by Pythagoras simply, that it will be root 2a. Let me show you how. Let's say it is A, B, C, D. So AC will be equal to root of A square plus A square. Because this is A, this is also A, this we need to find. Simply Pythagoras theorem, nothing else. 2a square. So it is simply root 2a. So if it is root 2a, the sides of this equilateral triangle will also be root 2a. Let us name this also P and Q. So we need to find the area of both the equilateral triangle first, then we will equate. So let's say area of triangle APB, the first upper one equilateral triangle. First of all, area of equilateral triangle is what? Root 3 by 4 into side square, whatever the side is. So root 3 by 4, in this case, the first case, side is A, root 3 by 4 A square. Then area of triangle AQC will also be root 3 by 4 side square, but the side here is root 2A whole square. So root 3 by 4 to 2A square. So just divide both of these. Area of triangle APB by area of triangle AQC is equal to root 3 by 4 A square upon root 3 by 4 2A square. So both get cancelled, and you get 1 by 2. So by this you can simply say area of one triangle is half the area of another triangle. So these were 5 questions. The remaining question we will discuss in the next video. Thank you.